Okay, so the problem we're looking at today is USACO 2019 December contest gold problem 3 of Moortal Cowmbat. So you can pause the video first and read through the problem yourself. Okay, I assume you read the problem. So basically what this problem is saying is you're given a string S and you're trying to change S so that S is only consists of blocks of at least k consecutive same letters. And there's a cost of switching every letter to another one, and you're trying to minimize this cost. So we can pause the video once again and think about this problem yourself. Okay, I assume you thought about it. So what's the first thing that we notice? Well, if you read the problem, you'll notice that there's a really annoying part. Is that the given cost of switching from letter I to J might not be the minimum cost, as you can maybe switch from I to K first and then switch from K to J. So that's quite annoying, right? So how do we tackle that? It's actually not that hard, because when you think about it, there's only 26 letters, meaning we can just run a Floyd shortest path algorithm that calculates the actual shortest distance between button I and J, and then we just store that as the distance that we used in the later calculations. Okay, now that we solved this annoying part, what about the rest of the problem? So this problem just gives off a really strong DP vibe, so that's what I did. I thought it must be DP, and it is DP. So intuitively, I guessed the state of the DP as Fij is the cost of making the first I letters legal with the last letter being J, and it is the actual state. However, the transition is the tough part about this problem. I could not think of the transition in the actual contest, so I had to look at the solution to finally come up with the transition. But so here's how the solution did it. So first of all, we have the DP state of Fij equals the first I, making them legal, while the last one is J, right? And now when we're transitioning, usually there's two types of transition with DP. The easiest one is transitioning by ones. Let's say we're trying to find F5 of something. Let's say F5A, right? So how can we find that? If we're transitioning by ones, we transition from F4 of something to F5A. And for F4 of everything, we find the optimal value. However, since we're trying to make this Fij legal, as if k is greater than 1, the only legal F4 that we can transform into F5A is F4A, right? And then the only F3 that we can transition into F4A is only F3A, and so on and so forth. So in the end, we're going to have a string of all A's for FNA, all B's for FNB, and all C's for FNC. And that's just ridiculous. That's meaningless, right? So we obviously can't just transition by ones, because in order to make it legal, we can never change the letter. So what about the other type of classic DP transitioning? Well, this will be transitioning by block. So usually, if you're trying to find F5A, you find an Fi minus L. You try to for Fij, you try to find a Fi minus L and then J, and then you find the optimal value along all L and all possible J for the L. So can we do that for this problem? So we can say transition from 3 to 5, and then 2 to 5, and then 1 to 5, and then see which one's optimal. Well, if we do that, it would be right. However, the time complexity will be incorrect, because Fij already have a time complexity of n times m, and now we're transitioning. Now we have to enumerate which I minus L to transition from. That'll give us a time complexity of O(n) squared. Sorry. So we can't transition by block either. Well, what can we do now? Because of this, I got stuck during the mock contest. However, the solution offered a clever way to do this. If we can't do either, why don't we do both? So what does that mean? Every time we can try two types of transition. Fij is first equal to Fi minus 1 J, right? That's obviously legal. And then we see whether that value is better, or whether Fij equals I minus K L is better. Now this L can be any number from 1 to M, right? It's just whichever letter we use as the last block. So what does that mean? It means for every letter we have two options to choose from. For this F5A, there's two options. We either add it onto the block of A before, let's say, so we either say that the previous block is also all A's, and then we add it to that block, or we can make itself its own block. Let's say say k is equal to 2, right? We can make its own block. So then we make all those whatever L we want because it doesn't matter, and we make this block all A. We make both 4 and 5 A, and it's its own block. So that's the second situation. So first situation is when you combine into last block. Second one is when you create your own block. So basically, you combine the two types of transition of DP, of transitioning by blocks and transitioning by ones. So that's pretty smart, right? And that's how this problem is solved. So here would be my implementation of that algorithm. So first of all, we have to pre-process with the Floyd algorithm to calculate the true cost of switching I and j. And then we have to pre-process a prefix sum of switching all first I letters into letter j. Because doing that, because when we're transitioning by blocks, if you remember, when we're transitioning by blocks, we have to find the cost of switching. We have to find the cost of switching the last k into I, into letter J, right? Because the entire last block is to be J. All these is to be J, and then the cost of switching those, making those legal, is included in FR-1L. So how to find that? Well, prefix sum can help us solve it in O1 complexity. So that's why we're pre-processing the prefix sum, and that's initializing the array of F. And we notice if I is less than K, well, obviously it's impossible to make it legal. And I didn't make it int max because it'd be kind of risky, as we have 185 as the n and 1000 as the maximum cost of switching two letters. So I just thought that's already 1e8. So if I do int max, it might not be enough. So I did 1e12. You don't have to do that. You can do like any other number basically, as long as it's big enough. Anyways, that's just set it to infinity, right? And then we start an actual DP. And this is transitioning by ones. This is transitioning by block. And we notice that if I is less than k times 2, we can only have one color. So that's why we only transition by ones if I is less than k times 2. And finally, we take the min of all these, we take the optimal, and when we reach n, we see whether ending the whole list, ending the whole string with A is better, B is better, C is better, and then we find the optimal value, and then we output that value as the answer. Okay, hopefully after this video, you know how to solve the USACO 2019 December contest gold problem 3 of Moortal Cowmbat. It's basically just DP with state transitioning of combining transitioning by blocks and transitioning by ones. Okay, I hope this video helped. Thanks for watching.